So how is all that information that we're getting through the neurons, that are transmitting through the different types of neurotransmitters, how's it being processed? So there's a couple ways we can process information coming from all these different neurons. One is what's called neuronal pools. As the name implies, I pool a bunch of neurons together in order to generate the information. So a group of neurons all do the same function. The advantage to that is, if I have a mistake, something gets broken down, something gets disrupted, it shouldn't disrupt the overall signal because I have a bunch of them doing the same thing, so there's redundancy. So it allows things to all continue on, even though one part didn't work, or two parts didn't work, the rest of it should make it work. So that's kind of the advantage to a neuronal pool. You can also have a convergence concept, where you can have lots of axons all coming together and meeting at one neuron. An advantage of that is I can gather a lot of information and bring it to one spot and then send forward one signal. So here, I have lots of things all doing the same thing, all going the same way, kind of their own thing, so if one gets disrupted, not an issue. Here, I can converge them together in order to bring all the information to one point. I can also do the exact opposite. I can do a divergence. I can take one neuron, have the axon come out, at the end of the axon branch out and go to multiple spots. So I can send one signal, but as it gets to the end, it branches and splits and sends each signal to every spot. That way I can have them all work together. I can coordinate the effort a little bit quicker that way. So here you can see the two things occurring where I have convergence and I have divergence. So how I'm converging multiple ones coming to one spot. Here I have one of them sending one signal and splitting between two of them to do the same thing. Neuronal pools may be multiple ones of these all working together to do the same task. Types of nerves. Well, neurons are the cells themselves, but nerves are what put all these neurons together. So when I ask what is a nerve, that's what it is. I'm putting a bunch of neurons, a bunch of axons together and creating one big long fiber, allowing it to send signals all together. Just like the fibers in your walls, or you're trying to send them along the wires outside on the telephone poles. You have different types of fibers in there that can do different things. If you talk about like internet cables, you're going to have some that send signals one way, some send signals the other way, and vice versa. So there are two types of fibers that are occurring here. There are sensory or afferent fibers that are made of primarily just sensory neurons. That's their job, pick up information, send it towards one direction. Motor neurons, or efferent, are made of motor neurons. They're just sending signals towards things like the muscles. There are three types of nerves made of these two types of fibers. So to make sense, you have motor nerves, which are just made of motor fibers, just sending signals in that one direction. It's a one-way street going just away from the central nervous system to the body. The sensory ones are made of just sensory fibers, and they're taking signals from the body and sending it to the central nervous system. And then you have mixed. You have both of them. It's a two-way street. You have information going towards the central nervous system, information coming on the same street next to it, going back the other way. They're going side by side. Could it cause problems? Yes, but it's going to be a little bit quicker communication back and forth between different regions that way. If you don't have to go all the way this way and then come back this way on single-lane roads, as opposed to having two roads going the same side by side like this. Nerves look like this. It's a big, large, bundled, individual axons that are bundled into a little bit bigger bundles, and a little bit bigger bundles, a little bit bigger bundles. That should look familiar because it's the same basic layout that muscles are laid out, with individual fibers wrapped into larger and larger bundles. Same concept. One of the key things about the way we process all this stuff is what we call reflexes. People always talk about reflexes, but they really don't know what reflexes actually are. What reflexes are is reflex is a shortcut. It's a shortcut in the system to allow quicker movements. It gets rid of the central nervous system in some ways. It basically shortcuts it back without going through processing to the brain, so you don't have to think about it. That means it's going to be faster and easier to do. So they're built in for protection. We call that a reflex arc. So I'm taking, normally the information would come from the sensory neurons, go all the way to the central nervous system, up to the brain, process, go back down to the motor neurons, and then make an action. These come towards the central nervous system, may hit things like the spinal cord, then turn right back around and shortcut. So they can immediately cause one specific action. Can't vary, they just do that action. So receptors at the end of the sensory neuron, it travels the central nervous system. The association neurons just reroute it right back to the motor nerves. They don't even go up to the brain, they just reroute it. And then you cause a reflex. There are a number of reflex behaviors that people are very familiar with. So for example, the withdrawal reflex, that means you pull away from something. Somebody goes to try to slap at your face, you pull away, you blink, you do those things like that, you pull your head back. Put your hand on a hot stove, you pull it back without thinking about it. That is a withdrawal reflex. The patellar reflex, or the knee-jerk reflex, causing us to kick out by hitting that particular nerve on below the knee, below the kneecap. There's a reason for that. Think about it, if I'm standing upright and I hit on my leg, I push away in order to push back away from danger. It's technically a type of withdrawal reflex, it's very specific. Some people have much weaker ones than others, some have very strong responses. The visceral reflex, these are your organ reflexes. So your stomach gets upset and you throw up. That's a visceral reflex. The gag reflex is part of the visceral reflex. Those are ones where our body just responds to a certain action to try to protect itself from the organs. So it's trying to expel things, get rid of things, do stuff like that in order to protect itself. Here's our knee-jerk patellar reflex. Hit across here, it causes you basically to extend your leg. Like I said, if you're standing upright and you get hit, you're going to push back and away. But you can see where something happens here. You can see the nerve goes up this way, goes right up to the spinal cord, and then transmits right back to the muscles, causing a quick reaction. Saves time, you don't have to think about it, there's nothing to worry about. But that's why people can't be accused, well, you blinked. Well, you do blink because you have to. Your body can try to fight it, it's just difficult.